So for this family of curves, then for this problem, so parabolas with vertex and focus on the y-axis. So in a Cartesian plane, this is the y-axis, and since vertex and focus on the y-axis, so therefore we can have this vertex, this one is the focus, so the parabola or the parabolas opens upward. Since opens upward, so this is now the standard equation. The quantity of x minus h to the power 2 then equals. So instead of using 4a, so we're going to use a because 4a and a are the same constant. So this is equals to a then times y minus k. Then from this y-axis, so h is equal to 0. Then in the x-axis, k is equal to 0. So this standard equation becomes x minus h is 0, quantity to the power 2, then equals multiply. So this is a times y multiply, so negative a times k, or this is equal to x to the power 2 then equals ay minus a times k. Then this time to find out the differential equation, since there are two arbitrary constants, the a and k, so we need to find the second derivative. So first, for the first derivative, the derivative of x squared, this one is 2x, then equals the derivative of a times y, this is a times y prime, then minus the derivative of a constant, this one is 0, or this is equal to 2x equals a times y prime. So this is now the first equation. Then to find out the second derivative from the first derivative, so the derivative of 2x, this is equal to 2, then equals the derivative of a times y prime, this is equal to a times y double prime. Then we need to solve for a, divide both sides by y double prime. So therefore, a is equal to 2 over y double prime. Then this time, we need to substitute this value for a from this first equation. So from this first equation, this is 2x equals a, and a is equal to 2 over y double prime. So this becomes 2 then over y double prime, then times, we still have this y prime. Then to simplify, so we need to multiply this whole equation by this y double prime. So distribute to this term, multiply. So this becomes 2x y double prime then equals to this term, multiply. So we can cancel this y double prime. So we have now 2 times y prime. Then observe that we can reduce, so we can divide or eliminate these 2. So this becomes x times y double prime equals y prime. Then equate to 0, so transpose to the other side. So we have now x y double prime minus y prime equals 0. So this is now the differential equation. Then for this problem, so circles with center on h and negative 5. So take note that the center of the circle is H and K. So therefore K is -5, and from the standard equation of the circle plus the quantity of y minus k to the power 2 then equals r squared, or this is equal to x minus h quantity to the power 2 then plus y minus k. K is -5 to the power 2 equals r squared, or this is x minus h quantity to the power 2 then plus, so we have this double negative, so plus 5 to the power 2 equals r squared. Then observe that there are two arbitrary constants, so therefore we need to find the second derivative. So for the first derivative, the derivative of this quantity of x minus h to the power 2, so using the chain rule that u to the power n, this is equal to n times u to the power n minus 1 times the derivative of u. So this is equal to 2 times x minus h quantity to the power 1 because minus 1 for the exponent times the derivative of this inside the parentheses. So this is 1. Then plus for this term. So we have 2 times y plus 5 quantity to the power 1 because minus 1 for the exponent. Then times the derivative of this inside the parentheses. So the derivative of y, that's y prime, then equals the derivative of a constant, this one is 0. Then to simplify, so observe, all terms are divisible by 2, so we can eliminate these 2. So we have now x minus h, then plus, distribute, so this is y prime, then plus, distribute, so 5 y prime equals 0. Then to find now the second derivative, to eliminate this last arbitrary constant, so the derivative of x, this is y, then minus the derivative of a constant, this one is 0, plus the derivative of y times y prime. So we can use the product rule, this is u times v, that's v times the derivative of u, then plus u times the derivative of v. So this is u, this one is v. So applying now the product rule, so we have v is y prime then times du, or the derivative of y, that's y prime then plus u is y times the derivative of v, so v is y prime and the derivative is y double prime, then plus for this term the derivative of 5y prime, this is 5 y double prime, then equals 0. Then to simplify, so we have 1, then this one is 0, so plus y prime to the power 2, so we have this 2y prime, then plus y times y double prime, then plus 5 times y double prime equals 0, or this is equal to 1, then plus y prime to the power 2, then plus, so we can factor out this y double prime, then we have now y plus 5 equals 0. So this is now the differential equation.